Okay, so let's start. Hmm. That day we have discussed about acids, है acid and bases. So what is strong acid? What is strong acid? Rudra, what is strong acid?
It's when they have more H plus ions.
What?
They have more H plus ions.
Ah, more H plus ions. And what is strong base? More OH minus ions. And what are the examples of strong acids? What are the
H2CO3.
H2SO4?
H2CO3.
H2CO3 is what?
Strong acid.
No. H2CO3 is a weak acid. It's not.
HNO3.
See. H2SO4, HCl. This is what? This is sulfuric acid. And this is hydrochloric acid. Hydrochloric acid. And one more strong acid I have discussed that day. You don't remember?
Is it HNO3?
Yeah, HNO3. Nitric acid. This is nitric acid. These are the strong acids. And what is strong base? What are strong base? Only two are there, NaOH and KOH. Potassium hydroxide, sodium hydroxide, and this K is potassium. Potassium hydroxide. Potassium hydroxide and sodium hydroxide. Okay. Now, what are weak bases? What are the examples? Weak acids and bases both. What are the weak acids? That day we have discussed which have less OH minus ions. And the examples are what? Come on, give me the example.
H2CO3.
H2CO3 and H3PO4. H2CO3 is carbonic acid and H3PO4 is phosphoric acid. Carbonic acid and this one is phosphoric acid. Okay. Now, what is weak base? This should be H plus now, less H plus ions, and in weak, less OH minus ions. And what are the examples of weak bases? MgOH twice. And what is MgOH twice? Magnesium hydroxide. Okay, so these are the strong acids, strong bases, and weak acids and weak bases. Now, one more thing is there, which is concentrated acid bases, and another one is diluted acid and bases. Now, what is concentrated acids and bases? Any idea about this concentrated word and this diluted word? Any idea? No idea? See, concentrated is what? In pure form. Means your acid and base will be there in a pure form. Okay, and what is diluted? Diluted means water is added. Water is mixed in your acid and base. This diluted form is not a pure form. In this diluted, the water is added or mixed. Water is added or mixed. So these are the concentrated acids. These are in the pure forms, and the diluted. Dilute itself means like water. So here water is added and mixed. Now let's learn about the process of dilution. What is the process of dilution? See, here what happens is, if let's say this is my beaker, and in this beaker acid is there, okay, and this is a vapor, this is a vapor. Now here, so in this beaker there is a acid. Now if we add water in the acid, then what happens? Then what will happen? Any idea? Rudronial, if we will add water in the acid, then what will happen? Then this vapor which is coming out from the acid will, it will come to our face, and our face will burn. It will affect you. Your face will burn. Your face will burn. In this acid, the vapor is there, and if we will put the water, then what will happen? The flow of water is very high. If we will pour a water in the beaker and if acid is there, then suddenly all the vapor of the acid will come out from that beaker and your face will burn. So that's why we never pour this water in the acid. That's a wrong process. What we do, we always we always pour acid into the water. Slowly acid we put into this beaker and we constantly stir it. Okay, we'll put the acid into the beaker. We'll never put the water into the acid. We'll always put the acid into the beaker and we will constantly stir it. This is the stirring thing. Okay, and we'll constantly stir it. Now you got this. What is the process of dilution? Rotonio, you got?
Yes.
Uh, Let me write. It is not. It is not water. Hello, Shaitan. You are late.
Yes, ma'am.
Okay, so let me just quickly. Okay, so that day we have already discussed about the strong acid and bases, right, Shazan?
Yes, ma'am.
And what is strong acid?
Ma'am, which does not mix well in water.
What? Which is having more H plus ions.
Oh, yes.
Okay. And what is strong base, which is having more OH minus ions? And what are the examples of the strong acids? These are H2SO4, HCl, HNO3, sulfuric, hydrochloric, and the nitric acid. And what are the examples of the weak bases? NaOH, KOH, sodium hydroxide, and the potassium hydroxide. And what are the weak acids? Which have less H plus ions, and weak base means which have less OH minus ions. And what are the examples of weak acids? The H2CO3, H3PO4, H2CO3 is C means the carbonic, P means the phosphoric. And what are weak bases? These are only one is there, which is MgOH twice, magnesium hydroxide. Now, apart from this strong acid, strong base, we have two more things which are diluted acids and bases. Now, what is the concentrated? Concentrated means our acid and base are there in a pure form, and the diluted acids and bases means the water is added or mixed in our acid or base. This concentrated one is in a pure form, but this diluted means the water is added in your acid or base. Okay, now this is the process of dilution. What is the process of dilution? Here, Shazan, you are understanding this part now? What is concentrated, what is dilution, what is strong, what is weak? Yes?
Oh, yes. Ma'am. Okay.
What? Okay. Now the topic is process of dilution. What is process of dilution? Let's say this is my beaker. In beaker there is acid and the vapor. And if we are putting the water into the acid, then what will happen? The vapor will come out in our face and our face will burn. So we never put the water into the acid. We always put the acid into the water, and the slowly acid will put into the water and we'll constantly stir it. Okay. So here it's like it is not water which is added to acid. It's a acid which is added to water. It's a acid which is added to water. It's a acid which is slowly added to water. And we constantly stir our solution. Okay, so this is done. Now here, let's go through this notes. What is this? What are the bases? The substance that furnish hydroxide ions, the OH minus in the aqueous solution, are called bases. Like NaOH, CaOH twice, which I've already discussed. This is the, this is the question like here. See, this is what, these are the, what are the bases? Which is dissolved in water to release the OH minus ions. And what are acids? Which are dissolved in water to release H plus ions. So what are the chemical equations of the bases? See, this is my, this is the example of base, sodium hydroxide. And if this sodium hydroxide is dissolved in water, means H2O, it will form Na plus and OH minus ions, means dissolving in water to release this OH minus ion. Now this potassium hydroxide, this is also dissolved in water to release this OH minus ion, and then potassium plus, K plus. CaOH, calcium hydroxide, which is also released in water to form what? Sorry, to release this OH minus ion. These are the strong bases. Sodium hydroxide, potassium, and calcium hydroxide. These are the strong bases. And what is the weak basis? This MgOH twice is the weak basic. Okay, weak base. And now if this is dissolved in water, it will also release the OH minus ion. But in the case of acid, If the examples of acids are dissolved in water, it will release the H plus ions. But here they are releasing the OH minus ions because OH minus ions is there in the base and H plus is there in the acid. Okay, got it? See, this is the example, the same example which I wrote. The NaOH means Na plus and releasing the OH minus ions. MgOH twice is MgOH twice is dissolving in the water to release the Mg2 plus and 2OH minus. This equation is a balanced equation. Okay. Hello, Safia. So now, Safia, we are discussing about the acids and bases. Okay, the strong acid, strong base, the concentrated dilution, and the process of dilution we have already discussed. Any doubt you can ask. Now, what are the bases? This you already know. Okay. What are Shazan? Do you know what are alkalis? That day I have told now.
Yes, ma'am. Yesterday you taught about alkalis.
So what are
No, I forgot.
you forgot? How you forgot?
No, I don't know.
Okay, read this line and this one and understand what is alkali. Read and tell me, huh?
Ma'am, an alkali is a base that
Hmm.
dissolves in water.
Alkalis are bases. Water soluble bases are known as alkalis. Alkalis are not acids, alkalis are bases. Okay, examples are these only: sodium hydroxide, potassium hydroxide, magnesium hydroxide. All bases do not dissolve in water. Alkali is a base that dissolve in water. That's why alkalis are known as water soluble bases. Alkalis are dissolved in water. That's why alkalis are known as water soluble bases, and alkali is a base. Okay, examples are the same as basics. The NaOH, KOH. See, here I have told that all bases do not dissolve in water. And alkali is a type of base that dissolve in water. That's why alkalis are known as water soluble bases. And the examples are these only: the sodium, potassium, magnesium. Okay, now you got it. What are alkalis? Shazan? Everybody, Safia and Rutronial?
Yes, ma'am.
No.
Ma'am, I
or
said
yes.
yes, ma'am. I said yes.
Okay. And what are the properties of the bases? These are the properties of the bases. Bitter in taste and the acids are okay. And the examples of the bases are soap, baking soda, milk of magnesia. It turns red litmus to blue, and for acid it turns blue litmus to blue litmus to red in color. If red litmus is dipped into acid, then it will be red only. But if blue litmus is dipped into acid, then it will change its color to red. So here these are the properties. Bases are bitter. Bases feel soapy to touch because the example is soap. Bases turn red litmus to blue. These we already know. Bases are electrolytes, means they conduct electricity in solution. Now these are the chemical properties of the bases. See here, what is the strong alkali? Means 2NaOH, NaOH only. These are the balanced chemical equation. Strong alkali plus carbon dioxide will give us the carbonate and water. Now these chemical properties you have to memorize it, or you have to practice it. So what is strong alkali? We'll take the example of sodium hydroxide, NaOH. If it's adding with carbon dioxide, it will form a carbonate, means Na2CO3 and water. Same as potassium hydroxide. If it will add with the carbon dioxide, it will form the potassium carbonate. This is the potassium carbonate and water. Now the next type of chemical property is they neutralize acids to form a salt and water. Means they neutralize what? Acid to form the salt, means calcium chloride, here iron chloride, to form the salt and water. These are the this is the next type of chemical property. The third one is metallic salt plus alkali will give the salt plus insoluble. Okay, let me salt plus insoluble plus metallic hydroxide. Now this is the fourth type. ammonium salt, alkali salt plus water plus ammonia. These properties you have to go through once. Okay, now what is the uses of bases? Any idea about what are the uses of bases? Do you know anybody? What are the uses of bases? Anyone? Safia, Rudra?
Ma'am, what are the
Any?
uses of bases?
Ah,
Ma'am, they are used for ma'am. It is used for hair products, and ma'am, it's used in food also, like baking soda and all are base. Ma'am, it's used for washing clothes. Ma'am, it is a daily. Means it is in all the things which we use it daily.
yes, good. See, first let us learn about the what are the uses of acids. Okay, then it will be easy for you. See, vinegar. Vinegar is a acetic acid. It is used to preserve the pickles and Chinese foods. And in pickles we put the vinegar. We add vinegar in the pickles, to preserve it. Now in stomach also hydrochloric acid is released. Why hydrochloric acid is released in stomach? To digest our food. See, it's written also helps in digestion. This hydrochloric acid is help HCl helps in digestion and kills the bacteria coming to the stomach. Means HCl helps in digestion also, and it kills the bacteria also which is coming to the stomach along with the food. If we are taking food and if in our food the bacteria is present, then HCl will kill it and it will also help in the digestion. Now the third one, cold drink contains carbonic acid. Oxalic acid is used to remove ink or rust stains. If okay, the boric acid is used as an antiseptic and for the eye wash. Sodium benzoate is used as the preservative in cold drink and foodstuffs. Orange and amla contains ascorbic acid, vitamin C to prevent scurvy. Okay, so these are the uses of acids. These also you have to go through it. You have to learn that what is the use of acetic, what is the use of HCl, what is the use of carbonic, oxalic, boric, sodium benzoate, and the ascorbic acid. Okay. Now let's see what are the uses of the bases. See, sodium hydroxide is used in the manufacturing of soap because soap is the example of bases. The soaps are there, baking soda, soaps, baking soda, milk of magnesia also. Okay, now this potassium hydroxide is used in the manufacturing of salt and soaps. Okay, this potassium is used in the manufacturing of salts and soaps. Sodium also help used in the manufacturing of soap, and the potassium hydroxide also used in the manufacturing of salts and soaps. And it is also used in the batteries. Means if anyone will ask you that which bases are used in the batteries, then you can say the potassium hydroxide is used in the batteries. Now, slaked lime is used in the manufacturing of bleaching powder. Okay, the bleaching powder is manufactured by this slaked lime. Okay, magnesium hydroxide can be used as an anti-acid. And what is anti-acid? Anti-acid is released in our digestive system when we have that acidity is forming in our stomach. Then anti-acid is released to, you know, anti-acid is a kind of medicine. Anti-acid is a basis. So we are learning about the uses of bases, so it will be there. Now this magnesium can be used as an anti-acid. Aluminium hydroxide acts as a foaming agent. Magnesium is used in making this bricks. Calcium is used in the drying agent, basic flux. Now these are the uses of the bases. You have to learn this. Now what is indicators? Okay, now what is indicators? Indicators. Anyone know what is indicators? Safia, do you know?
Yes, ma'am.
Yes.
They show whether a solution is acidic or basic.
Very good. Yes. The indicators are those type of chemical substance, those chemical substances which help to detect the nature of other chemicals. Okay. Which help to detect the nature of other substances. Sorry, other substances. Oh, I'm not able to write. Just a minute. Okay, so any example of indicator, Shazan? Like indicator is like those type of chemical substance which help to detect the nature of other substance. So any example of indicator? Anybody? Rudroniel, what is the example of indicator? Do you know?
Turmeric is a natural indicator.
But yeah, but it's like the chemical substance which help to detect the nature of other chemicals. So it can be the litmus solution, the litmus
Yes,
paper,
yes.
है ना? Yes. Okay, those chemical which help to detect the nature of other substances. Example is litmus solution. Now, these are of four types. The natural means the indicators are of four types. Not this, sorry. The indicators are of four types. The natural, synthetic, olfactory, and last one is universal. Indicators are of four types: the natural, synthetic, olfactory, and universal. First, we will learn about these two. Okay, what is olfactory and what is universal? What is olfactory and what is universal? Now, what is olfactory? Olfactory means the odor, and this means what? Anybody? Shazan, what is this? What is the meaning of this?
Which one? Odor.
Ah,
Ma'am, it's like a bad smell.
yeah, only smell. Yes. So those substances whose odor changes in acidic or basic media. Those substances whose smell changes. Okay, whose smell changes in acidic or basic media is called as olfactory olfactory indicators. And now what is the example of this olfactory? Vanilla, onion, clove. Clove means long. Okay, now see, if we take the paste of, let's say we are taking the paste of this clove. Okay, the paste of this clove. Now if we will smell the paste of this clove, then it will be something different. Now if we will add the acidic solution in this clove, then the smell will be different. Now let's say we are adding the bases also we add in this paste, then also your smell will be some of different kind. The natural paste is a different smell. Now your acidic paste is a different smell, and your basic paste is a different smell. That's the meaning of this olfactory. Means those substances whose smell changes, like here my clove paste smell is changing if we are adding acid to it or if we are adding the bases to it. Now here those substances whose smell changes in acidic or basic media. It means if we are adding the acidic thing or if we are adding the basic media to our clove, then what's happening? Then the smell of clove paste is changing. Natural paste smell is different, and if we will add the acidic media to it or the basic media to it, then the smell is different. That's why, so this is known as the olfactory universal. And one more point is there: the smell of onion and vanilla, diminishes in a base but and remains as it is in an acid. See here what happens. In the clove, if we are adding the acid and basic, the smell is changing. Now in the case of this onion and this vanilla, what's happening? If we are adding the acid and if we are adding the base, if we are adding the base, see, the diminishes in a base means our smell gone. But if we are adding the acid, the smell remains as it is in the case of this acid media. But here in the clove paste, what's happening? If we are adding acidic, smell is changing. If we are adding basic, then also some different smell is there. But in the case of this onion and vanilla, if you are adding the acid into it, the smell is not changing. Only the smell is changing if we are adding the basic media into it. Okay, everybody understood about this? What is olfactory indicators? Any doubt? Rudra, Shazan and Safia, any doubt here?
No, ma'am.
No? Okay. Safia,
No,
any
ma'am.
doubt? Sure? Okay. And what about Ruth?
No, no.
Okay, so this olfactory is odor, means smell. The smell will change. Now the second one is about the universal indicator. What is the universal indicator? So let's talk about the universal indicator. See, the universal indicator is those indicators which not only detect the nature of the acid and bases, but it will also detect the strength of the acid and basic. See, it is the those indicators which not only detect the nature of other chemicals in the sense the acidic media and the basic media, but also determine their acidic and basic strength. Acidic and basic strength. Now, can you give me any example that which kind of thing is there which will determine the acidic and basic strength? Any example? Shazan, any example, any idea? See, the litmus paper will only get to know that if the color is changes into red, then it is acidic, and if the color is changing into blue, then it is basic. But which will determine the strength? Which will determine the basic and acidic strength?
Is it pH value?
Yes, very good. The pH value will determine the acidic and the basic strength. Why? Because see here. Where is it? Yes. See, this is my pH value, pH scale. Here, this 7 part is my neutral part. Okay. And this part is my basic, and this is my acidic part. Now, this pH value is determining the strength. If my pH value is 14, then it's very strongly basic. Okay. And let's say if my pH value is 0 or 1, then it is strongly acidic. And if my pH value is 7, then it's neutral. Okay. And for example, let's say if my pH value is 9 or 8 or 10 or this 1, sorry, this 11, then what? Then we will say it's a weak basic. Okay. And here the 3, 4, 5 pH value is also my weak acidic. The left hand side of the neutral will be the acidic part, and the right hand side of the neutral will be the basic part. And the 14 is the strongly basic, means this pH value is determining the strength of our acidic and the basic media. And the litmus solution will only help to determine that which is acidic, which is basic. Litmus will not help to determine that, like the strength, you know. But this pH scale will help us to determine the strength also of the acidic and the basic media. Here the 14 you understood, keep strong basic. Here this side is the weak basic, this side is the weak acidic, and the 0 is the strongly acid, and this is 7. See, it's like Vibgyor, the rainbow color. V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, and R for red. This is what? This is Vibgyor. And Vibgyor is the color of rainbow. Okay? You can learn like this. Now this part you understood? See, how we will determine the strength. We will take the pH paper and we will dip this pH paper in a chemical solution. And what is the full form of this pH? Anybody know what is the full form of pH? Let me show you. See, this is here. It will be. Oh, where's it? Okay, let me write it. What is the full form of pH? pH means the potence. Potence means the potential. Potence is a German word. Okay? Potence is a German word. And potence means the potential of, and H means the hydrogen ion. So pH means the potence of hydrogen ion, means the potential of the hydrogen ion. If we will dip this pH paper in a chemical solution, then it will give me the color like this. It will be this color, this color. So we will keep this scale here, and then we will see that which color it is coming. It is coming the weak acidic, weak basic, strong, or weak or the neutral. So we will determine like this the strength. This is known as the universal indicator. One. Here, see, what are indicators? Indicators are the substance that change their color, change their odor when added into the acid or an alkaline solution to indicate the presence of the acid or bases. See, and there are four types: the natural, the synthetic, the olfactory, and the universal. And what are the natural and synthetic ones? See here. Natural is what these indicators are found in nature of the plants. This natural indicator is found where it is found in the nature of the plant. Example is the litmus solution. So these are the indicators you can learn. I'll write it also. And what are the synthetic indicators? Synthetic indicators are the indicators which are synthesized in a laboratory or industry are known as the synthetic indicators. And the natural are what? The indicators which are there in the plant, and the synthetic one which is synthesized in the laboratory or industry. The same as like synthetic cloth, the natural cloth. Okay. And what is the olfactory? We have already discussed the smell of the two indicators which help to detect, and the universal is the strength. See, to judge how strong a given acid or base is, that's called a universal indicator. So here, let me write quickly, then you guys will see. This is the indicator part. This is my acid, let's say, and here is my basic base. Okay. So here, first, if I am writing the red litmus. Now, anybody tell me, in acid part, what will happen, and in the basic part, what will happen? Shazan, Safia, and Ruth, come on, quickly, fast.
Ma'am, in base it will turn blue.
Yes, turns blue.
And, and if you put the red litmus in acid, then it will be red only, ma'am.
Means no change.
No change.
And now for blue litmus.
Ma'am, red and blue, ma'am. Red and no change.
Yes, very good. Red and no change. And what about the turmeric? The haldi. Turmeric is haldi. What about this haldi part? If we will add acid into the turmeric, then what will happen? Any idea? No change. But if we will add base is, for example, my soap. If we are adding the soap into the turmeric, then it will change its color to red. Okay. The turmeric, if we will add the acid into this, then it will be no change. It will be as it is, the yellow color. But if we will add base into the turmeric, means the soap, if we will add with haldi, then what will happen? It will change its color to red. Now, the fourth part. What is phenolphthalein, right? Yeah. Phenolphthalein. Here, any idea, Shazan? If we will add this acid into this, then what will happen? If we will add basic, then what will happen? If you will add this acid in the phenolphthalein, then what will happen?
Ma'am.
Any idea about?
No, ma'am.
No? Okay.
I know for turmeric, ma'am, there is no change. But if you put turmeric in base, then it becomes red. But for that.
Here also in this, if we will add the acid part, it will be no change. And here, if we will add the base into this, then it will become pink in color. And the last one is the beautiful one, the methyl orange. If we will add acid into methyl orange, it will turn its color to red. And if we will add this basic into the methyl orange, it will turn its color to yellow. So this is
unique one.
Yes?
Unique one, ma'am.
Unique one. Yes, this is the unique one. Here in both the acidic and basic, the colors are changing. Okay. So the this part is done. What is this is the strength of acid and base. How we will get to know the strength? From the pH value, from the pH scale we can write, not the pH value, from the pH scale. The strength of an acid or base depends on the number of H plus ions, because acid is H plus and the basic is OH minus. Okay. So here, what is this? The larger the number of H plus ions produced by an acid, the stronger is the acid. If acid will produce the large number of H plus ion, then my acid is stronger. Here in the pH scale, if my pH value is 0, then it is producing a more H plus ions. If my pH value is 14, then it is producing more OH minus ions, because this is the 7, here is the 14, this is the basic part, and this is the acidic part. Okay. What is this? Larger the number of H plus ions produced by the acid, stronger is the acid. Similarly, larger number of OH minus ions produced by a base, stronger is the base. So the nature of the solution depends upon the concentration of H plus ions in the solution. So this is the strength, and this strength will get to know from the pH value, from the pH scale. What is this pH scale? See, it is a scale used for measuring the hydrogen ion concentration. The P stands for, see, I told na ki P stands for potence, means the potential of the hydrogen ion, which means power. P means power, potential means power. So this potence means power in the German. Okay. So pH is the number which indicates the acidic and the basic. The left side of the 7 is full acidic. See, the left side of the 7 is full acidity increases, and in the right side of the 7 full alkalinity increases, means the basic part, the alkaline part increases, because alkaline is a pure water soluble basic. Okay, so he defines the pH in simple terms as the solution the solution having higher concentration of hydrogen ion has a low pH value, and the solution having low concentration of hydrogen ion has higher pH value. Means if you will write 14, then it will have a high pH value. If you will write 1, then it's a high pH value in terms of the acidic part, and 14 in terms of the basic part. Okay, so this is all at the, like, you have to go through this notes, then you will get to know everything. Each point will be clear. What is neutral? Neutral is my 7, you already know. Neutral substance has a pH value of exactly 7. Neutral substance such as a pure water. Neutral is what? Is a pure water. And if we go this side, it will be the acidic kind of water, the acidity, the acid rain also, hai na? Which is neither acidic nor basic. My 7, my neutral one is neither acidic nor basic, and it has a pH value 7. A substance having pH value 7 will have a no effect on litmus or any kind of common indicator. If we will dip a litmus solution into the chemical, it will not have any effect, because it is neutral and it's having a pH value 7. Now, acids have a pH value less than 7. This part is the acid part. A solution whose pH is less than 7 is known as the acidic solution, and the pH whose value is greater than 7 is known as the basic solution. More acidic solution, the lower will be its pH. Okay, if my acidic solution is more, then what it is, the lower will be its pH. A solution of pH 1 is more acidic than the solution of pH 4. As I've already told you that 1 is the more acidic as compared to 1. If 1 is less acidic, okay? So so if we are comparing the 1 and 4, so obviously 1 is more acidic as compared to 4. And here if we are saying that 14 is more basic, so if we will compare 14 with 11, then 11 is a weak basic as compared to the 14. Okay, so you understood this part. This is the pH value, this you already know. This is the